All right, you've dragged yourself back for more factorial action. I'm both impressed and deeply concerned about your social life. But today, ladies and gents, things get suspiciously simple because we're dealing with a for loop. Yeah, the loop that's about as exciting as alphabetizing your sock drawer, but secretly makes your coding life embarrassingly easy. Now I realize we've gone through recursion, where we pretended maths had depth, and the while loop, which was like babysitting an indecisive toddler who never knew when to stop. But here comes the for loop, strolling in with all the irritating confidence of someone who color-codes their bookshelves. And let's face it, we secretly love that type of organizational arrogance, even if we'd rather not admit it. Let's cut to the chase. The for loop is the smartest choice for factorials because factorials, frankly, are predictable and boring. You know exactly what they're going to do every single time, multiply numbers from one up to your number. It's not exactly a plot twist, is it? This is maths, after all, not a crime thriller. Because factorials follow a predetermined path, like your uncle retelling the same stories at every family gathering, the for loop is the perfect tool. Unlike recursion, which dramatically repeats itself until it reaches a breakdown, remind you of anyone. Or the while loop, constantly asking, are we there yet? The for loop is disciplined. It calmly states, here's where I start, here's where I end, and this is how I'll get there. No fuss, no confusion, no unexpected existential crises halfway through. Factorials, if you haven't learned by now, and really if not, I'm genuinely worried for you, are just numbers multiplied together in sequence. It's basically a glorified multiplication table for people who want to seem smarter than they really are. Think of it like making a sandwich. Stay with me here. You start with a piece of bread, your result, which we'll call 1 for convenience. Then you layer stuff on top, one at a time, a slice of cheese, multiply by 2, some ham, multiply by 3. Maybe lettuce, if you're pretending to be healthy, multiply by 4, and so forth. Each step builds up, layer after layer, until you have a glorious sandwich, or in our case, a deliciously calculated factorial. What makes the for loop perfect here is that it does all of this automatically. It's the coding equivalent of a factory conveyor belt, efficient, precise, and requiring almost no brain power. Basically, it's your ideal coworker. Here's how factorial calculation looks with a for loop. No, I'm not going to show you code, calm down. It's literally this easy. Start with the number 1, because 0 won't get you anywhere, mathematically or metaphorically, and then multiply it by each number in sequence until you reach your target. Honestly, if this approach was any simpler, we'd just be pointing at numbers and politely asking them to multiply themselves, which, sadly, hasn't worked so far. You begin at 2 because multiplying by 1 is as pointless as your gym membership. And you keep going up to whatever number you picked at the start. With each step, you multiply your current total by the next number in line. Eventually, you run out of numbers and you're left with your factorial. This entire process is about as thrilling as reading the phone book, but it's undeniably efficient. Now, because we must uphold the sacred tradition of boring examples, let's slowly and painfully work through factorial of 6. Don't pretend you're not excited. First, your total is 1. Great start, you're already winning. Multiply by 2, you get 2. Hold on to your excitement, it's overwhelming. Then multiply by 3 and you're at 6. Gasp-worthy stuff, this. Multiply by 4 and the crowd goes wild. It's 24. Multiply by 5 and we hit 120, because why stop when you're having this much fun? Finally, multiply by 6 and voila, you're at 720, the final thrilling number. And that's it. 6 factorial is 720. No drama, no tears, just pure methodical boredom. You're welcome. Since programmers love pointless rivalries, let's pit the for loop against the while loop, just for kicks. Initialization. The while loop awkwardly sets up separately. It's like assembling flat-pack furniture, tedious and frustrating. The for loop smoothly integrates initialization, like ordering furniture already assembled by someone who actually knows what they're doing. Checking conditions. The while loop checks its condition every single time, like a paranoid friend who asks if the door's locked every 5 minutes. The for loop calmly and silently handles it, no nagging involved. Updating values. The while loop requires you to explicitly update your variables, reminding you each time to keep counting. The for loop elegantly does this automatically, assuming you're too lazy or forgetful to manage it yourself. Spoiler alert, it's right. Essentially, the for loop bundles up all your coding chores and does them for you without complaint. It's the loop you pretend you don't need, but secretly depend on. Quick word about efficiency, because programmers love numbers more than actual humans. The for loop is wonderfully efficient. It runs exactly as many times as needed and then stops. No unnecessary detours, no excessive memory usage, no drama. It's predictable, it's reliable, it's also painfully dull, like your friend who orders the same sandwich every single lunchtime. But efficiency-wise, it's brilliant. Time complexity, linear, space complexity, constant translation. It won't hog your computer's memory or crash the moment things get tough. Unlike recursion, which is more like your dramatic ex, it just quietly gets the job done without fuss. Let's admit it, teachers adore the for loop. It's structured, clear, and easy to grade. It perfectly demonstrates fundamental programming principles without causing students emotional breakdowns. The for loop teaches iteration, structured problem solving, and how to pretend you're organized even when your life is a complete mess. Students who master for loops learn a critical programming lesson: how to keep their code readable. Trust me, your future self, who will be angrily debugging your horrible old code, will thank you. Still awake? Let's give you some homework to complain about later. Write a program that displays factorials for numbers 1 through 10. You know, just in case your friends are dying to see factorials at parties. Modify your factorial program to sarcastically comment on each step. Let your computer mock you for using factorials in the first place. Try calculating huge factorials and watch your integers overflow dramatically. It's like maths-based fireworks. The for loop makes factorial calculations laughably simple. It neatly handles initialization, updating, and conditions all at once, because doing things separately is exhausting. It's efficient enough to handle large factorials without your computer rebelling. Teachers love it. Students tolerate it. Everyone pretends they don't secretly prefer it. Next time we'll dig deeper into recursion again, but now focusing on what's actually going on inside your computer's memory when recursion tries its usual drama. Spoiler alert, it gets ugly. You've been warned.